All right, we'll get started then this morning. I'm going to introduce 7.4 this morning, but again, I'm going to try and keep this under 10 to 15 minutes so that you have about a half an hour to 40 minutes to really nail down 7.1 to 7.3 and ask any questions that you might have. I know it's not terribly difficult, but I still want to make sure that we've got that down. Okay, so today what we're looking at is the reciprocal function. So a reciprocal function, if you remember a fraction, let's say a fraction of 3 over 4. If I take the reciprocal of it, I flip the fraction and it becomes 4 over 3. That's the reciprocal of it. Now if I had 3, which is a whole number, so that's 3 over 1, the reciprocal of it is 1 over 3. So what we're going to do today is we're going to take a graph and we are going to do the reciprocal of that graph. All right, now we're going to do it again. I'm going to show you two very different ways in which you can do it. The first way works great. You can always use a table of values. The second way is just an understanding, and it'll be very much similar to the absolute value one, in which I graph the original equation and then I take the reciprocal of the new equation. Okay, so take a look at page 310, and it gives us, it says sketch the graph of y equals f of x and its reciprocal y equals 1 over f of x, where f of x is equal to 2x. Okay, so to begin with, f of x is equal to 2x. So that's the original graph. So I'm going to quickly sketch that graph. So that's the graph of a line in which I start at 0 and 0. I go up 2 and right 1. And that's that right there. Now I'm going to mark in these coordinates right here because these are going to be important to us as we go through. Okay. So now if you're looking at the page, the first way that they show you is write out a table of values. Okay, so we can write out a table of values then. So let's start by going x, f of x, and they put in the following coordinates. So -4, -3, -2, -1, 0. Oh, they put a couple fractions in there. Let me do that as well. Those become important as well in this. So -1/2, -1/4. I'm just going to put it 0, and then I'm going to do 1/4, 1/2. So I'm not putting the 1/6 in there. but I'll explain that. 1, 2, 3, and 4. Okay, so to get f of x then, I plug in all of these x values in for x, and I multiply them by 2 to come up with my y value. So multiply it by 2. Minus 8, minus 6, minus 4, minus 2, minus 1. That'll be minus a half. That would be 0. That's going to be 1/2 again. That's going to be 1, 2, 4, 6, and 8. All right. Okay. So there are all the coordinates along this graph then. So all those values are on that line as they should be. Okay. Now what I want to do is I want to take 1 over f of x. Sorry if that looks a little crammed. So my next graph is going to be y equals 1 over f of x. So that's going to be my y values here. So all I simply do then, and this is why I say this is a great way to do it. If you ever run into difficulty, this is your bailout plan, okay? All right, so I'm going to take 1 over all of my y values off of my original graph. So this is going to give me minus 1 over 8, minus 1 over 6, minus 1 over 4, minus 1 over a half. Here's the first key one, minus 1. Just going to make that go like this. I'm going to make a point of that. Okay, so then now I got something interesting. I've got minus a half there. So when I take 1 over minus a half, I end up with minus 2. Okay, so my fractions are going to become larger values. All right, now here's the next very important part of this whole process. 1 over 0. Well, if I use my calculator and I punch 1 over 0 in, I get an error. Why? Because this is an undefined value. This is what we refer to in for you. So where y is equal to 0 is undefined. That creates what we call an asymptote. So I'll show you that in a minute. All right, now I'm doing 1 over a half again. Well, 1 over a half becomes 2. 1 over 1. Well, that's still 1. So I'm going to make a note of this guy as well. Because when x is a half, it's 1 on the f of x graph. And when x is a half, it's also 1 on the 1 over x, f of x graph. And I'll explain that in 1 second. And then as my values get larger, these values are going to get smaller because they become fractions. 1/2, 1/4, 1/6, and 1/8. Okay? So the first thing that I want to point out, all right, there's 2 very important things. Number 1, these squared boxes here, they're called invariant points. Okay? They're called invariant points. And what an invariant point is, oops, missed the T. What an invariant point is a point on the original graph that is also on the new graph. All right, they exist in both graphs. Those are what we call invariant points. So when x is a half and x is negative a half, when we have f of x, it equals -1 and 1. It also equals -1 and 1. And the reason behind it is because that is a reciprocal function. All right? So now, if I were to plot these points, I'm going to sketch these fairly quickly. So the first thing that I do, excuse me, the first thing that I do is I mark off where my asymptote was. All right? So what you're going to see is this axis has what I call an asymptote. An asymptote is a line where there's an undefined value. And what happens with the asymptote is the graph approaches that line but doesn't hit it. So I'll make sense of that in a second. This is also an asymptote right here. And again, you'll see why in a minute. Okay? So the first thing that I do is I mark off my asymptotes. The second thing I do is I mark where my invariant points are. So that's where x is equal to 1. All right? Now, I'm going to, from this point, if I were to label all of these, this is what that graph would look like. This and this. Okay? So I'm going to make a bigger graph, and I'm going to explain this a little bit better using the second method of this graph. Okay? So here's what's going to happen next. So I said to you earlier, the first thing I do is I graph f of x equals 2x. So one, two, 1, 2, 2, 1, 2. So I'm going to expand this. I'm going to make this a little bit larger. All right. So 0 and 0 is my starting point. I go up 2, and then I go over here to write 1. Okay. So first thing I label. Are my asymptotes. Okay, my asymptotes are, in this case, along the y-axis and along the x-axis. All right? Now, the second thing I label. Now, I said to you, I label the invariant points. There's an easier way to remember this. I label where y is equal to plus minus 1. So where y equals 1 and minus 1 on my new graph, or sorry, on my old graph, I label it. So y equals 1 right here. Y equals negative 1 right there. And if you recall from this graph, that's when x is equal to negative 1/2 and x is equal to positive 1/2. All right, but I need to label where it's equal to plus minus 1. Now, here's the game changer right here. All right, I need to sketch it. Well, I need to explain the sketch to you so that this makes great amount of sense. All right, if I look at the x values going out this way, let me go back to this. As I look at my x values, as they get larger, so 1, 2, 3, 4, what's happening to my y values in my new graph? They're getting smaller. They're getting to be, because 1 over 2, sorry. So when I've got 2, 4, 6, 8, so I got 1/2, 1/4, 1/6, 1/8. As I move out, my graph gets smaller. So as my x values get larger, my y values start to get smaller and smaller and smaller. They approach this asymptote right here. All right? So as my x values get larger, my y values get smaller because I'm taking the reciprocal of them. So this coordinate right here is when x is 2. Well, I put it into the original equation. So 2x, so that's 4 then. Y is equal to 4. Well, y is now equal to 1/4. When x is 3, I get 6. Now it's 1/6, 1/8, 1/10, 1/12, and they get smaller and smaller and smaller as they go. Now here is the biggest thing that you have to remember. all the values between, and I'm looking at the y-axis right now, the y-axis. So from 0 to 1 on the y-axis, all of those values are fractions. Okay? So I only used 1/2 there, but you can see when I took the reciprocal of 1/2, it became 2. The reciprocal of 1/3 is 3. The reciprocal of 1/4 is 4. 1/5 is 5. 1/6 is 6. 1/7 is 7. And so on. So what's happening here is the line goes up very steep. From when you get to y equals 1 here, towards the y-axis, all right, that's where all of these y values from here to here are all fractions. They're all fractions. And when you take 1 over a fraction, you get a whole number. So my graph goes up until you hit the 1, and then it goes down. The same thing occurs in the negatives. Right there, those values, these x values, are getting smaller. So is this. And then it goes towards the y-axis. So the actual graph of the reciprocal function are these two lines in blue. Now again, this is a very important graph to us. We need to understand what this graph looks like. And the reason we need to understand it is in grade 12, there are 5 graphs that we have to be able to do without thinking. Quadratic function, done, check, we've already done that. Cubic function, we'll look at that in a little bit greater detail. Absolute value, we've just spent time on it. Reciprocal, we're going to spend more time on it. And then finally, the square root graph, which we'll worry about next year. So this graph right here, the graph of any reciprocal function, this is what it's going to look like. All right? So let's look at filling in the box. I want to look at filling in the box on page 311. Okay? So the domain then for the original graph, which was y equals 2x. Here, I'll write this out on the board. Okay? So when we're looking at y equals 2x and y equals 1 over 2x, my domain, range, asymptotes. What else do they have? Can x equals 0? Okay, I'll answer those as we go. And then the last thing is that invariant points. Okay, so the domain for y equals 2x. Well, y equals 2x is this green line right here. We know that the domain for this is negative infinity to positive infinity. The range, also negative infinity. Oh, drew this poorly. Negative infinity, positive infinity. Asymptotes, none exist, so I put none. Okay, and then the invariant points. I believe they list these off. So for this graph, my invariant point would be 1/2 and 1 and negative 1/2 and 1. Okay? Can x equal 0? Yes. Can y equal 0? Yes. What happens to the value of y as x increases? So as x gets larger here, what's happening to y? It's getting larger as well. What happens to the value of y as x decreases in value? So x is getting smaller over here. So is y right now. Here's my blue. All right. So my domain for this, well, how far left does it go? It goes to negative infinity. How far right does it go? It goes to positive infinity. However, x cannot equal 0. So how do I write that out then as my domain? I write it out like this. X such that X is an element of all real numbers. X cannot equal 0. Done. Okay? Same thing for Y. How low does it go? Negative infinity. How high does it go? Positive infinity. So, Y such that Y is an element of all real numbers. Y cannot equal 0. Asymptotes, they're equations of lines. So we have to remember that. This is kind of key for us. We have to remember that they're the equation of the line. And in this case, my line is this one right here. So that's when Y equals 0. And my other asymptote is when X equals 0. So that's this guy right here. Can X equal 0? Answer, no. All right. Can Y equal 0? Again, no. What happens to the value of Y as X increases in value? All right. Whoops. So what's happening? As my X gets larger here, what's happening to my Y value? They're getting smaller. Smaller. All right. And as X gets smaller, what is happening to my Y values? They're also getting smaller. They're getting closer and closer to, sorry, not smaller, my bad. They're getting larger. So it's the opposite in this case. So what happens to the value of Y as X increases? It gets smaller. What happens to the value of Y as X decreases? It gets larger because I'm moving in the negatives. So therefore, the higher up I go, the larger that value gets. What are the invariant points? They're the same. Okay, they just come over here. Now, I'm not sure I have to list them for the first one, but I certainly do for the second one. Oh, this should be -1 as well. Should be -0.5 and -1. So make a note of that. It's where Y is equal to 1 and Y is equal to -1. All right. Okay. So I'm going to look at example 2, and then I'm going to finish up here. I've already taken too much time. Example 2 says, consider the function f of x equals 2x plus 1. What is the reciprocal of the function? Well, the reciprocal of that function then is f of x equals 1 over 2x plus 1. That's essentially what the reciprocal of it is. Or y is equal to, it doesn't matter. Determine the equation of the vertical asymptote for y equals 1 over f of x. So the vertical asymptote occurs, basically it's the same as a non-permissible value. Okay, what can x not equal? Well, 2x plus 1 can equal 0. 2x can equal -1. X cannot equal -0.5. That is the equation of the vertical asymptote. X cannot equal -0.5. All right. Now, I'm going to show you, using a graph now, why that happens. So, I'm going to graph the original. So where do I go with the original? 0 and 1. That's where I start. That's my y-intercept. Then I go up to and right 1 to right here. And I draw this line right here. Okay. So the first thing, and I should go back, let me go back to this and do this one more time. My asymptote, my vertical asymptote, that's what this should have read right here. My vertical asymptote always occurs where y equals 0. Because when I take 1 over 0, I get an undefined value. So where does it equal 0? I draw my dotted line right there. At x equaling -1/2. That's where it crosses the x-axis. That is where it's undefined. Now that I've got that in there, I mark off my 1 and my -1. So here's where 1 is. Here's where -1 is, down here. And then sketch it. This is still an asymptote. And that's my other asymptote. That's my vertical asymptote. Okay? So when I'm drawing the original, my asymptote goes in right here where it crosses the axis. That's where I put my asymptote in. All right? Okay, so I'm going to leave that for a moment. I will come back to that Monday. I just wanted you to have a look at it for the weekend. That's good enough. All right. So today, a couple things. One thing I want to make a note of. Okay. So today I'm going to put an assignment on Teams for you that I want you to take off of Teams, do it, put it back on Teams. Now, I learned something last night from Austin's mom. One of the ways in which I have been trying to figure out how do we get things, and you guys are really, really good. So it may not affect any of you, but I'm telling every one of my classes because my other classes aren't really good at this. But to change something to a PDF file, you go into notes. Go into notes on your phone, and in notes, you take a picture, and you can take multiple pictures, and then at the end, you can send them all as one email. It will convert it to a PDF for you. So go to notes, take a picture, and you can do it that way. Now, I think, I'm not 100% sure, the grade 12s have done it last night. They found it easier just to take it off, save it to OneDrive, and then add it into Teams. So if that works for you, no problem. I just need you to find one method that works well for you. But like I said, you guys are really good at it. But I'm going to try Teams today and use the assignment function on Teams to put an assignment in there. And I'll do that by 10 o'clock today. You'll have that assignment up. Okay. Any issues with 7.1, 7.2, or 7.3 that you want to ask about today? Are we all finding the absolute values fairly straightforward?
Yeah, I think for the most part. I have one question, 7.3, but it's towards the end, so it can wait unless it's like.
Now we can let's do it now. Which one is it?
Okay, 10 on 307.
Okay. All right. A company is building a movie theater based on similar movie theaters, and that an analyst tells the company that its earnings per day are based on the solution y equals the absolute value minus x squared plus 48x minus 512, where y is in thousands of dollars and x is in the number of movie screens. If the company can build between 16 and 32 screens, what is the number of screens within this range that will give the maximum profit? All right. So you could graph it, but I'm gonna use a different method for this. I'm going to substitute in 16. And then I'm going to substitute in 32 and get my range that way. All right. So absolute value of negative 16 squared minus or add 512 minus 512. Okay. So let's substitute that value in, and then let's solve for it. So I've got I got this equaling 0. So a profit of 0. Okay? And then I'm going to substitute in, what was the next one? 32 screens. Oh. Okay, something tells me I'm going to get the same answer. Yep. So I get y equals 0. All right. So it says if the company can build between 16 and 32 screens, what is the number of screens within this range that will give the maximum profit? So we need to find the maximum profit. And if this is 0 and 0, so let's look at a possible graph right here. I'll put this as 16 right here. So that's 16. This would be 32 out here. So that's 32 and 0, 16 and 0. And my graph is going to look like this. Right?
Right.
Okay. What's halfway between 16 and 32?
24.
24. Let's put that into our equation now. And see what we get. I get 64, which means that if you have 24 screens, you're going to get a maximum profit of $64,000. Okay, now, what does the absolute value have to do with this? Next to nothing, because if I were to draw this graph out as it's written right now, this would come down here like this, right? And then because of the absolute value, it would go back up like that due to my absolute value. But it's saying that somewhere in between 16 and 32 into that range, there is a maximum value that will give you a maximum profit. Well, we've already done all of these with quadratic functions. So the reason I took the halfway point is because 16, excuse me, 16 and 0 and 32 and 0 are on the same plane. So therefore, I know that halfway in between there is my vertex of this quadratic function.
Right. Okay, thank you.
Hey, no worries. All right, does anybody else have questions that you want to ask about today? We're okay? All right, I guess we should discuss tomorrow. Division. There we go. All right. So tomorrow is a scheduled day for parent-teacher interviews, which means you wouldn't have had school tomorrow. So I don't have a problem if you guys want to sleep in tomorrow and not have class tomorrow morning. That's okay by me. We are on a good pace right now. We have 2 sections left after we complete chapter 7, which will be about Tuesday or Wednesday next week. So hopefully everybody's okay with that.
Yeah, that sounds good. And I think there's only like 2 units per chapter, maybe.
2 sections, really?
Yeah, 2 sections left in
Okay.
8.1 and 8.2.
Okay. Yeah, so we got time. So we'll be okay. Today's what, 23rd, 30th? Yeah, so we've got a week left in April. We aren't going to rush this. These 2 sections are pretty important for next year. So, all right. So what I'll do then is I will post that assignment right away here today. And I'd like you, if you wanted to start on 7.4 and look at the first little bit, you certainly can. It may be a little more difficult, but it's up to you. Otherwise, I'll just leave the mics open for another probably 15 or 20 minutes if you guys just want to visit and talk. I know some of you are probably going stir crazy at home and not getting out, so I'll leave that open. If you have anything else, just ask. Okay? So I'm just going to shut my mic off. Go ahead, Morgan.
When will that assignment be due?
You can hand it.
Like on Monday?
Yeah. Yeah, I think you'll probably get it done fairly quick today if you get it started.
Okay.
Okay. All right. There's no other questions. I'll just put my mic on mute here. Just remember I'm on here, so keep it relatively PG. And if you have any questions, just ask.